Hello all, here are a couple of examples for connecting exponential graphs with context. So in this example, we are looking for an initial value right down here. So a couple of things we need to start connecting and putting together with our other equations of exponential functions. We are still generally following this a times b to the x idea, where this is still our start or initial value, and that's almost always going to be when your time is 0. So to answer this particular problem, I need to look for where my time is 0 and simply grab the y value here. So I know the correct answer for this starting value is 500. Now the other concept that we're going to see start happening here is looking at how much this changes, and again, that means we're going to look at this one value. That's going to again be our critical. When we start to look at how much of a price or a value has changed from the start to, again, that first time increment. So while it doesn't ask for it, in this particular problem, I'm seeing that we're starting at a time of 0 and a value of 500, and at a time of 1, it looks like we're down to, well, right in between 2 and 300, so at 250. And so what this is telling me is that my base is going to be half of what it used to be. So in two different ways, I can say this is 50% of the starting value. I could also say, because this is exactly 50, that we lost 50% of the starting value. And we're going to see that more as we go through our other problems. My second problem I got is talking about carbon-14. It's actually a pretty common real-life example that shows up in a lot of problems. And it says here that carbon-14 loses about 10% of its mass every 1,000 years, and that the sample that we're starting with in this problem has 600 grams. So what I'm looking at here before I start to try and really pick out an answer is I've got a starting value of 600 grams, so in terms of writing out that a times b to the x, I know that my starting value again is 600. And really what I'm after here to be able to see this graph correctly is going to be looking at what number I get to use for b, and the key to that here is that it loses about 10%. So the way I'm going to be thinking about this problem is that if no change were made, then I'd have 100% of it. So if I didn't make any difference, then I'd have 100% of what I started with. It's not increasing, that's not decreasing, it's simply all of what I had. So to do a loses 10%, that's going to tell me that my base here is going to be a 90%, or as a decimal, a 0.9. So if I go to write down this equation, the equation I would write here would be 600, which was my starting amount, and then a 0.9 to the x. So I'm not going to expect this graph to go down dramatically because we still have 90% left. It's a pretty good chunk each time, and I could start to fill out this graph by multiplying by that 0.9. So if I did 600 times a 0.9, I get 540. And I could continue again multiplying by that 0.9 each time to continue to find these values if you like. Because we are looking for a graph, we are also able to use Desmos. So another option is, of course, desmos.com. And look at the calculator so we can see what that graph looks like. So I'm not going to scroll all the way down to show you the correct answer, but that is more than enough information to either match points, the 0 and 600 and the 1 and 540, or to actually just enter that equation at Desmos to see what that graph would look like. For my third and last example I'll be doing here, we're dealing with bacteria growth over time. Again, a very common kind of question. And again, I'm still tying all of my old skills back into this, trying to figure out what is our starting value. So again, at time equals 0. What's our initial amount? And that appears to be 50. And again, we want to look at that critical 1, that's always the easiest, to try and figure out what kind of change was made here. So in this case, if I were solving this like my writing equation kind of thing, then I would say that an A times a B is 60. So when I'm looking at this, I know that 50 times B is 60. And I'll be dividing by 50. And so what I'm going to get here when I divide that out is B equals 1.20. So as we interpret this now to try and figure out what the correct answer is, I'd ask you to remember the previous example where I told you that we always are looking at 100% as being everything that it was before. So I need to know how much change was made here. So to change from 100% to a 1.2 or from a 1.0 to a 1.2, that means we increased by 0.20, or in other words, we increased by 20%. So again, I'm not really going to scroll down and look through everything here, but that does tell us the correct answer to this problem. I hope these examples have been useful, and I'll see you on Zoom if you don't understand what's going on here. Have a wonderful day.